Hello everyone, my name is Azamat Jamanov. I welcome you on Computer Networks 2 subject. In this course, we are going to describe with you the CCNA Routing and Switching 3 book and a Routing and Switching 4 book. So, Routing and Switching 3 book consists of the scaling of the network, and this is lesson 1, an introduction to scaling networks. The scaling means that something that can expand in the size. And first of all, we are going to take a look for the hierarchical network model, or it can be called differently like a borderless LAN design. In this model, we have 3 layers: access, distribution, and core. 3 layers of the switches which are working with the different tasks, with different responsibilities. Starting from access layer switch is responsible for interconnecting end devices. Like here we can see end device is the network printer. Network printer is interacting with the network through the access layer switch, and all other devices in this network model will be connected only to access layer switch. You will never have such kind of situation that the computer will be connected to distribution layer switch or the core layer switch. In this model, we have role of the switches who are giving access. This kind of switches are called access layer switches. Access layer switches provides the security. If someone wants to have connectivity to the network, that person will be able to be connected only to one of the ports of the access layer switch. It means that you have to provide security right here in this part, in the access layer part. And if someone with computer X will try to be connected to the switch 2, so you can make filtration right here. Okay, so you can make decision. Does this computer have ability to be connected to the network or not? So one of the security which can be used in the whole network, in all local area network, is called the port security. And this port security is the function of only access layer switch, because only access layer switch provides ability to be physically connected to the network, and there will be no ability to be connected to the distribution layer switch. So the port security is the function of only access layer switch. Let's take a look for the model's characteristics. One of the characteristics is the scalability. This networking model can be scaled very well due to the fact that it consists of some models. And in case if your organization is going to be connected with the new department, I mean if new department will start work inside this organization, this department can be connected to one of the switch, for example, in which we have about 20 ports. So let's say here we have 20 computers. And afterward, we'll be just connected to one of the distribution layer switch. Whereas the functionality of distribution layer switch is distribute communication between access layer switches. And also you can provide such kind of additional links between access layer switches and distribution layer switches, so that in case if switch 7, S7 and D1 will have problems, then switch 7 can be connected with the D2 and can still work and provide service for all of these 20 computers. So when you are making such kind of interconnectivity, backup interconnectivity between switches, it is called a redundancy. Or in other words, it can be just called like a backup. First characteristic is scalability. It can be scaled very well. Second characteristic is redundancy. So you can provide some redundant components like switch S2 can be connected also to D1, and switch S3 can be connected to D1, and S1 can be connected to D2. So that in case if one of the link will fail, another link will start to work. Another characteristic of this model is the performance or the aggregation. So you can aggregate the link between switches. In case when you have interconnectivity between switch 5 and D3, and imagine that the speed between them is 1 gigabit per second, and when computer 3 wants to communicate with computer Y, they are communicating with the speed of 1 gigabit per second. If printer starts to make communication with the same device or with any other device by this link, then they share this channel into two parts. I mean, the half 0.5 will go here and 0.5 will go here. But in case if they have third device and fourth and fifth, etc., so if there will be a lot of devices which are connecting to this switch, and if all of these devices are going to be communicate with other devices out of this segment, then they will share, all of them will share the single link. So, and 1 gigabit per second will be divided by n, whereas n is the number of hosts which are bounded with this device, with the switch 5. So in this situation, we are going to have some issues with the speed. And to solve this problem, we can have the performance or the link aggregation mechanism, and we can provide connectivity between switches like this, so that both of these links are going to be one virtual channel. Here is used a special technology which is called the Ether channel technology, which can provide a logical channel of multiple links. So you can even have here 3 or 4 links. Why Ether channel is used? Because if you will connect switch 1 with switch 2 like this, and if they will be connected to such kind of computers like A, B, and C, and when computer A will make communication with all others, computer A will send the broadcast, and this broadcast will come to switch 1. Due to the fact that this is broadcast, switch is resending this information to both links, and when this broadcast frame will come to switch 2, switch 2 will resend it to B and C, and also it will resend it to switch 1 again. And at the same time, we have this frame. It will be also redirected to B and C and to switch 1. So that, and here we'll have endless loop. And we don't have mechanism which is called like a TTL in layer 2. So that is why we have to provide configurations of the Ether channel on our link, so that switch will think that this is single link and will send information according to a spatial key, which we are going to speak about a little bit later. Let's continue with our characteristics. What about security? So we already mentioned that we have port security here. So port security can be configured on access layer switch, and in distribution layer switch we are able to configure a filtration which is called ACL, access control list, which can provide the filtration between networks and between separate hosts. For example, you may have such kind of filtration like PC3 is not able to communicate, is not able to contact to the internet, and when information comes, the frame comes to D3, D3 distribution layer switches actually can work as a layer 3 device as a routers, and they can make filtration, and we can make such kind of configuration like PC3 is not able to communicate with internet, so that if request is directed to the internet, then D3 will deny this communication. But in case when PC3 will try to be connected to one of the local computers, then this communication can pass without any failure to computer, for example, PC10. So this kind of filtration, like an ACL, is also the part of the security characteristics of our model. Well, if we'll speak about manageability and maintainability, then it is very easy to manage such kind of hierarchical model due to that fact that every switch is doing its own job, its own responsibility. And maintainability, it's also easy to do because you know which switch are responsible for which function. Let us take a look for logical and physical topologies of LAN model. Well, we have logical topology, which is looking like this, and most of people think that switch 1, S1 has to be connected with D1, and here we have to have a long distance, and we have to have long distance between all of these devices because this drawn like this, but it is just a logical topology. But in case if you'll take a look for the physical topology, you may find out that in physical topology all of these devices can be placed in single rack. Okay, so that all of the access layer switches, distribution layer switches, and the core layer switches can be connected to the single rack in physical topology. And by the way, about core layer switches are distributing traffic between distribution layer switches, and also they are connected to the router, and routers are connected to the ISP. So for example, in our organization there can be 2 ISPs, and in case if something wrong will be with the connectivity with one ISP, your connectivity can be redirected through another ISP. Let's take a look for the convergent network. Many years ago, there were many types of the separate networks, like data networks, voice network, and the video network. And after what, technology has been changed, and nowadays all of these technologies can be just converged, like merged into single network, so that through the single network we may have connectivity of the data, we may transfer the data, we may transfer the voice, I mean the voice over IP telephony, and we can also provide the television network, the TV network inside the organization through the same Ethernet links. And now it's time to take a look about for analysis in a local area network. We have 3 main analyses. They are data flow analysis, user community analysis, data store, and data service analysis. Whereas data flow analysis is one of the important analysis which we have in the network, which provides us ability to measure the real speed of the network, so that in case if you have an organization and in your organization you have a topology like this, and here we have some servers, and if you made up the order to have so that network engineers will do this work, and at the end you want to test what is the result of their work, and in case if they have placed here the links, each of the link of your network will be, for example, as 100 megabits per second of the bandwidth, then you have to expect, for example, 90 megabits per second of the good put, because we have some device delay, we have the protocol overheat, and when you will make a test with the specialized software, you may see the real result. Like when you are making connectivity between computer A and one of the servers, then you will have your real result, which will be shown to you like uh, in the graphical applications, so that you may have a result, for example, 50 megabits per second. So after having such kind of connectivity test, you may ask your engineer what went wrong, what is not correct, so that then you can just say to him or her that she or he have to do this job one more time, so that you will, as a result, you will have a proper network connectivity. Another type of analysis is the user community analysis. User community analysis is the process of determining the future plans of the organization in which you are working, or maybe this is your organization, and you have to analyze how many users do you have currently. For example, your boss told you that you have to buy an equipment or buy equipments which will satisfy current situation networking requirements in this organization. And for example, this 100 people are working in this organization. And you may think that, okay, if we have 100 people who are working, or 100 hosts, then we have to buy, for example, 24 port switch. We have to buy such kind of 5 switches, and it will be quite enough for us. But first of all, you have to also ask, but what are expectations in the future of this company? So how many people will be approximately work in this organization? Maybe everything will be automated in future, so that there will be the number of users will be decreased, or maybe vice versa. Maybe now it is 100, but after 2 or 3 years it will be 200 or even 500. So in case if your organization is going to grow well in future, then you have to make analysis. What kind of switches to buy? Those switches which are expandable very well, or those switches which are fixed very well. I mean, not expandable, but fixed. And in case if you are buying fixed configuration switches, then the benefits of such kind of purchase is that you spend less money, but disadvantages that if your organization will scale well in future, then your devices will be changed to another devices, like scalable devices, which will cost 2 or 3 times more than you spent for the fixed configuration switches. So that before buying any equipment, you have to make a user community analysis, and you have to make analysis of how many users will work after 3 or 5 years in this organization in which you work now. Data stores and data service analysis is the analysis of placing equipment in correct places. I mean, to make allocation correctly. And in case if you have a server room, so it will be better that your servers are going to be connected into this by single access layer switch, due to that fact that between servers there can be a replication process, and this replication process takes much traffic. And in case if you are placing your servers into different access layer switches, and if they will start to make replication, they will take these links. So, and if they will take much time, I mean, if they will use these links to make replication, to copy all of their content, then other devices which are placed on the same switch will be impacted, negatively impacted, because they will not have good bandwidth here, because the link will be very busy. Now let's take a look for the switch form factors. We have three types of the switch forms. They are fixed configuration switches, modular switches, and stackable switches. Whereas fixed configuration switches are those switches which are fixed with the amount of the ports. And in case if you are buying switch with the 48 bits, with the 48 ports, then in this case, this switch is not expandable very well, but it can be expandable. So you can make connectivity from one switch to another by the basic line, by the basic Ethernet cable. So in case if you have the speed of ports as 1 gigabit per second, so interconnectivity between these two switches will be 1 gigabit per second, and all other devices which are connecting on both of the switches will share the speed of only single link. Or maybe you can be connected like this. So then you will use the link, the shared speed of 2 or 3 links, but it is called fixed configuration switches. Whereas modular switches consist of the chassis, the box in which we have the motherboard, and when you buy the board with the motherboard, inside the box with the motherboard, inside it you have nothing, because this is just the empty fields of the models. So that, and if you have your first 48 users, then you can connect here a new model, so other models will be empty. So in case if your organization is scaling and you have more users, then you can place new model. And when you will place all of these models will work as the single switch with the power of the single switch, because they are connected to this single bus to the main board, and the same as you are connecting to the single computer, multiple hard disk drives into the single board. And imagine that this is SATA 3. It will have a great speed. Alright, and the third type of the switch is the stackable switch, in which we have stackable connectivity, and we have backbone cable, spatial cable, which so this is C, which is providing very high speed between interconnectivity of the switches. From the other side, we have normal Ethernet ports, which are connecting to the hosts, but from the back side we have specialized cables, backbone cables, which are interconnecting your host, so that and you connect one single to second, second to third, and in this example third to fourth, and fourth to first one. And you can connect your switches with the backbone cable up to 9 switches. So, and from 9 switches you can have the effect of the single switch with a lot of ports. When you are selecting the switch, you have to pay attention on 3 main factors. They are port density, forwarding rates, and the bandwidth aggregation. Whereas the first one is just amount of the ports on your switch, which will be the proper way of selecting the amount of the switch ports according to requirements of your organization. So you may have starting from 4 ports on your switch and up to 1000 plus ports on single switch. It's up to your organization and it's up to your budget. Whereas the forwarding rates is actually the maximum speed, maximum amount of bits per second that your switch is able to generate. Sometimes some vendors provides you the device, for example, no-name device is giving you a switch with, for example, 48 ports, and each port speed is 1 gigabit per second. And you immediately think that if you have 1 gigabit per second, 48 ports, then you have to have 48 gigabit per second. It is not always like this. Some vendors, like no-name vendors, can provide you such kind of device, and you will buy it, and afterward you will connect all 48 ports, and when you will have connectivity, when you will use for 100% your switch, it will work, for example, for only 50%, so that its forwarding rate can be 24 gigabits per second, but it can have 48 ports with 1 gigabit per second. It means that only when in the scenario when you have only up to 24 ports, your switch will work for 100%. But in case if your amount of useful ports more than 24 in this example, then other speed will be shared on the ports, so that up to 50% loss you can have. It depends on the vendor. So in our situation we have Cisco catalyst switches, and the forwarding rate is equal to number of ports multiplied by the speed of each of the port. Some switches can work mostly in general by default. Switches are layer 2 devices, and some switches can work with the layer 3 also, with the layer 3 and layer 2. That kind of switches are called multi-layer switches, and they can work with layer 3. It means that they can make routing between local area networks, and it means that also they can make a filtration with the ACL like a router. And now it's time to just overview of the features of 3 layers which we are discussing today. Access layer switch features, the port security. Only in access layer switch we have port security. It can provide the VLAN connectivity. It can have fast Ethernet, gigabit Ethernet, or 10 gigabit Ethernet. It can provide the power over Ethernet. Like you may have connectivity from switch to IP telephony, which will get the data by this cable, and power supply, or power, it will get the power, so that without additional power adapter, your IP telephone or IP camera can work, and this is very good feature in the situation when you don't have ability to provide the separate power line till your devices. And in case if you have 50 IP cameras and 200 IP phones, then the impact of the power over Ethernet will be very great, because you don't need to buy all of these adapters, additional adapters, and you don't need to place these power cables, and it's good advantages actually. And the link aggregation, so you can aggregate links between the distribution access layer switch, and the quality of service also provided by the access layer switches and all other switches, and with the quality of service, it is possible to provide the priority of the different types of the frames. Whereas distribution layer switches may have ability of supporting of layer 3, means that they can work as the access with the ACL, and they have the high forwarding rate, and they have some redundant components, and also the port security policies as access list, and the link aggregation, and the quality of service. Whereas core layer switch features layer 3 device, very high forwarding rates, redundant components, link aggregation, and quality of service. This is the end of the first chapter. It is just overviewing of the borderless LAN design, and it can be called the hierarchical networking model. And starting from the next lesson, we are going to have very interesting topics like an STP and HSRP, GLBP, and so on. If you have any questions according to the material which we study, you can do not hesitate to ask me about them by using these email addresses. I hope that this lesson been informative for you. Um, and if you like this video, you can subscribe to this channel to have new fresh video material. Thank you guys. See you.